Hello everyone, welcome back to our channel Problematical. We were discussing exercises of sets chapter 1 class 11th maths NCERT. Let's start with exercise 1.5. First question, let U is equals to universal set is given to you, 1 to 9 elements. A and B are also, A, B, C are given to you. You have to find the respective values. First, A dash. A dash is A complement. Now we know that complement of any value would be universal set minus that particular set's values. So A complement will be equals to A universal set U minus A. Universal set contains 1, 2, 3, 4, 5, 6, 7, 8, 9 elements, and A possesses minus 1, 2, 3, 4. So removing these elements from U, you're left with 5, 6, 7, 8, and 9, which is your A dash. Second, B dash would be U minus B. So from the universal set, remove these elements and write the remaining elements, which will be 1, 3, 5, 7, 9. These are even numbers. Remove the even numbers, you're left with odd numbers. Third, E union C would complement. So first, A union C would be A united with C. Write the elements of A, 1, 2, 3, 4. C contains 3, 4, 5, 6. So add 5, 6 to it. These are A union C, and you have to take the complement of this. So from the universal set, remove these elements. You'll be left with 7, 8, and 9. Fourth, A union B full complement. So uniting A with B now. 1, 2, 3, 4, 2, 4, 6, 8. 1, 2, 3, 4, 6, and 8. And taking complement of that, which means U minus these values, you're left with 5, 7, and 9. Fifth, A complements complement. Now A complements complement. So if you consider this as the outside complement, this can be written as U minus A whose A complements complement. But instead of doing like this is a property where we know that the answer is going to be A. However, we can solve this. Let's first calculate A complement. A complement is already calculated, and this is the value, which is 5, 6, 7, 8, and 9. Now, let this value's complement is to be taken, which means A complements complement will be equals to 5, 6, 7, 8, 9's complement, which means you have to remove these elements from the universal set to get the answer, which will be 1, 2, 3, and 4, which would again mean this is A. So A dash dash will be equals to A. Sixth, B minus C. So you're removing elements which are common between B and C, and then you also have to take its complement. So there should be a complement of B here. B minus C whole complement. Let's calculate B intersection C. So this would be B minus, what is B intersection C? B and C, 2, 4, 6, 8, 3, 4, 5, 6. So 4 is the only element which is common between these. And 6 is the other element which is common between this. So 4, 6. Complement. Subtracting these elements from B, we'll get 2 and 8. Now 2 and 8's complement, which means all the elements from the universal set except 2 and 8, which would be 1, 3, 4, 5, 6, 7, and 9. Next, if U is a universal set, find the complements of each of the following sets. So first, A complement will be equals to, from the universal set, remove elements A, B, C and write the remaining elements D, E, F, G, and H. Again, B dash would be, remove all the elements from U which are in B, which is D, E, F, G are to be removed, D, E, F, G to be removed, and the rest are to be written A, B, C, H. C dash would be A, C, E, G are to be removed, A, C, E, G are to be removed, and the remaining are to be written B, D, F, H. D complement. Remove these. B, C, D, E, F, G, H are present. So these are your elements of D complement. Taking the set of natural numbers as universal set, write down the complements of the following sets. So taking set of natural numbers as universal set, U is given to be natural numbers. You have to find the complements of the following sets. Since the questions are written in set builder form, your answer should also be written in set builder form. So if this, let us consider these as A, B, C, D, E, F, E, F, G, sorry, this would be G, H, I, J, K. So you have to find A dash, A complement. X is an even natural number. Now we know that natural numbers can be either even or odd. So if you remove all the even natural numbers, you'll be left with odd natural numbers. Similarly, your B is a set of odd natural numbers. So your B dash will be a set of all even natural numbers. X is a positive multiple of 3. So all natural numbers are positive numbers. A multiple of 3, which means your X is any value which is not a multiple of 3. X belongs to a natural number and X is not a multiple of 3. X is a prime number. You can see that D dash should be X belongs to a natural number and X is not a prime number. X is a natural number divisible by 3 and 5. So E dash should be X such that X belongs to N and X is, you have to, your E is x is divisible by 3 and 5. That means a number which is divisible by 3, both 3 and 5. That means a number is divisible by 15. So you can either write that the number is not divisible by 15, because that number will not be divisible by 3 and 5, or you can write neither 3 nor 5. We will go with 15. X is not divisible by 15. X is a perfect square. So f dash should be x such that x belongs to n and x is not a perfect square. Seven. G dash is equals to x is a perfect cube, so x belongs to n and x is not a perfect cube. X plus 5 is equals to 8. H dash will be, it's given that your h is x plus 5 is equals to 8. So x, we know that x plus 5 is equals to 8 after solving will give you x is equals to 3. So it's specific that if you convert it into Rooster form, you'll be left with h is equals to a singleton set with the value 3. So here you can write this as a set of all x such that x belongs to n and x is not equals to 3. Ninth, I dash is equals to, again, 2x plus 5 is equals to 9. So if you solve 2x plus 5 is equals to 9, your 2x will be equals to 9 minus 5 is 4, x is equals to 2. That means I is again a singleton set where x is equals to 2. Because these are linear equations, your x will always be a linear value. X will always be a single value, sorry. For linear polynomials, x will hold only a single value. So any value except for 2 would be the complement, will be present in the complement of the set. So A dash is x such that x belongs to n and x is not equals to 2. Apart from solving it out, you can even write over here, instead of this, x is not equals to 3. You could also write x plus 5 is not equals to 8. Even that will hold the same value, that x is not equals to 3. Or here, you can write something from the given question, 2x plus 5 is not equals to 9. Either way, the answer will remain same. Next, j is x greater than equals to 7. When you say x greater than equals to 7, which means x will hold values from 7, 8, 9 till so on. So by default, j dash will hold values, since j is a universal set, is a set of natural numbers. It will hold values 1 to 6. Now you can write this in the set builder form as j dash is a set of all x such that x belongs to n and, or instead of and you can write comma 1. You need not write 1 because it's a natural number. X is less than equals to 6. Next, 11th, x is a natural number and 2x plus 1 is greater than 10. One second. Sorry, yeah. So 11th, x is a natural number. X belongs to n, and 2x plus 1 is greater than 10. 2x plus 1 is greater than equals to 10. Now there was no need to mention this natural number, but they did so. So let's rewrite it. This is k. If you solve this equation, 2x plus 1 is greater than 10. Now, inequality chapter comes later in this course, but inequality also you can add and subtract on both sides without changing the meaning of the inequality. So, your 2x plus 1 minus 1 is greater than 10 minus 1. I'm subtracting 1 on both sides. I'll teach you how to understand this from two methods. One by the rules of inequality, where I'm subtracting 1 on both sides. You'll get 2x is greater than 9. Now I'm dividing 2 on both sides. So 2x upon 2 will be greater than 9 upon 2. Therefore, x will be greater than 9 by 2. Now, which are the natural numbers which are greater than 9 by 2? Natural numbers greater than 9 by 2. 9 by 2 is 4.5. So beyond 4.5, we'll have 5, 6, 7, 8 till infinity. By default, your k dash will be equals to 1, 2, 3, 4. And then you can write it in set builder form. Now, you can view this by a different method as well. 2x plus 1 is greater than 10. So let's put x is equals to 1, smallest natural number. Let's see if the equation holds true. 2 into 1 plus 1, which means 3 is greater than 10. This means for x is equals to 1, 3 is greater than 10. The equation is false. It's universally false. 3 can never be greater than 10. So x is equals to 1 is not the required value, which means in the set of k, x is equals to 1. X is not equals to 1. 1 cannot be element of k. X is equals to 2. Again, you have 4 plus 1, which means 5 greater than 10. Equation is false. X is equals to 3. 3 into 2, 6. 6 plus 1, 7. 7 greater than 10. Not true. X is equals to 4. 9 greater than 10. Not true. X is equals to 5. 11 greater than 10. True. Beyond this, if you keep on increasing the value of x for all these values, your equation will hold true, which means x can have any value except for these 4 values, 1, 2, 3, 4, for a set of k. So k dash in set builder form will be equal to x such that x belongs to n and 1 less than equals to x less than equals to 4. Next. Use a universal set A and B are given. You have to verify these. Now it's not mentioned that you have to verify these by a Venn diagram or by the values, directly placing the values. So we'll directly place the values. The Venn diagram question will be covered further. So A union B complement is equals to A complement intersection B complement. We know that this is De Morgan's law. So let's calculate the value of LHS and RHS and say if they match. See if they match. A union B whole complement. What is A union B? Uniting the values of A and B. It would be 2, 3, 4, 5, 6, 7, 8. Taking the complement of it would be subtracting this value from universal set. So you're left with 1, 9. RHS. RHS is equals to A complement intersection B complement. What is A complement? Universal set minus these values, which would be 1, 3, 5, 7, 9. Intersection B complement 1, 4, 6, 8, 9. If you intersect these, you'll be left with 1. 5 is not common, 6 is not common, 7, 8, 9. So here LHS equals to RHS. Second, you have to prove that A intersection B whole complement is equals to A complement union B, A complement union B complement. It should be B complement. Again, LHS will be equals to A intersection B whole complement. A intersection B. What is common between A and B? 2, 3, 4, 5, 6, 7, 8. Nothing else is common. So, taking its complement, we'll be left with 1, 3, 4, 5, 6, 7, 8, 9. RHS is equals to A complement union B complement. Already calculated these complements. You can just rewrite them over here. 1, 3, 5, 7, 9 united with 1, 4, 6, 8, 9. This will be 1, 3, 4, 5, 6, 7, 8, and 9. So from these two equations, we can say that your LHS equals to RHS. Draw appropriate Venn diagrams for each of the following. So, A union B whole complement. First, you should draw A and B. Now, since there are 4 questions, I'm drawing 4. We'll have to draw 4 Venn diagrams. I'm just drawing the outlines and the common part in each. First, second, third, fourth. Since in each value you have to deal with 2, you're writing 2 values. Now, for each Venn diagram, you can draw multiple Venn diagrams and then merge them, but we'll try and do it in a combined fashion. So let's use different colors for different combinations. A union B whole complement. So we should only be we should be only shading the final answer over here. First, let's see what is A union B. We know that A union B would be A united with B. Let's name them. This is your A, B, universal set. Again, A, B, and universal set. So this portion would be A union B, all portion from A, and all portion from B combined. Its complement would be anything but this region. So from the universal set, subtracting this region. So instead of this region, we'll have to shade the exterior region. This would be the required answer. Second, A dash intersection B dash. Now, if you consider A dash, this would be A dash, except for A, you have to take the whole outside region. This would be A dash. A dash and B dash. What would be B dash? Sorry, A dash will be exterior of A. So this part of B will also be included. B dash would be excluding B, everything outside B, which means part of A which is not equal, not common with B, and the outside region. Now, by observation, we have to take intersection. What is the region common between this? From these, the exterior portion is common. So this part is not common. This part is not common. Everything outside is common. So let me draw it by a single color. Next, A intersection B whole complement. This region is A intersection B. So from the universal set, you have to shade every region except for this region. So it would be this exterior region, including B part and including A part, but not the common part. Next, A dash union B dash. So A dash, again, anything but A region, which is this outside region, B's region, which is not part of A, intersection union B dash. So let's draw B dash. B dash should be anything but B region, which is this region and the outside region. Again, by observation, what would be union of this? Anything which you can see shaded in this particular figure would be considered as union. So let's draw it by a single color. Outside region plus this region, B's part, plus this region. This is uniting A dash and B dash. A intersection B whole complement and A complement union B complement. Next, let U be a set of triangles in a plane. If A is a set of all triangles with at least an angle different from 60 degrees, what is A dash? Now, let's draw a triangle, a few triangles. This is a triangle. If it is an equilateral triangle, you know that all sides will be equal, in which case your all angles will be equal and each will be of measure 60 degrees. If you have another triangle, and here you have a third triangle, here all angles are 60 degrees. So you can have a scenario where only one angle is 60 degrees and the other two are not equals to 60 degrees. You can also have a scenario where all angles are different or same or similar, or two are same and the other one is different, but either way none of the angles is equals to 60 degrees. That is the third scenario which is possible. When you say that U is a set of triangles, so U is set of triangles, and A is a set of all triangles with at least one angle different from 60 degree. So this has two angles different from 60 degree. This has three angles different from 60 degree. Both would be considered in a scenario where at least one angle is different from 60 degree. So in this second scenario and third scenario is A, at least one angle different from 60 degree. Now in a plane, triangles can exist only in three scenarios. So A dash would be, universal set would be all three triangles. So from these three triangles, removing second and third scenario, you're left with only first scenario where all triangles are equilateral. Next, fill in the blanks. A dash union A dash. Uniting A dash with A dash. So the scenario is A union A dash. There's something wrong with my screen, that's why. A union A dash. In any set, if you unite a set with its complement, you'll always get a universal set. Second, phi dash intersection A is equals to dash. Now phi is nothing. So if you have a universal set, your phi dash will be your universal set because u minus nothing will give you u itself. Now from u and A, u intersection A, amongst u and A, what are the elements which will be common? We'll be left with A. So this value will be u intersection A, which will be equal to A. Next, A intersection A dash. A and A dash, there's nothing common between A and A dash, therefore it's phi. U dash intersection A is equals to, now your U dash means if phi dash is equals to U, if you take the complement of U, which means you're subtracting U from itself, you're left with phi, nothing. So U dash can be written as phi intersection A. What is common between phi and A? There's nothing common between phi and A or phi itself. So that concludes you this exercise. Thank you.